Howdy folks, and welcome back. We are now getting into section 4.3, which is right triangle trigonometry. So right triangles is probably one of the most common ways to define the trig functions. So we're going to see how that works. So by restricting angles to the first quadrant, we can now deal with positive values only for x and y. This allows us to define the trig ratios more generally. So if we created a right triangle, which is not indicated currently, but if we put a little square there, that'll do it. We can now identify the sides in relationship to one of the angles. So in this case, if our angle down here is theta, we can identify the sides as follows. So we have the opposite side, which is, again, straight out and away from the angle itself. You have the side that's adjacent to the angle. So again, it's right next to it. And then the third side, which is always unique because it's opposite the right angle, and that's your hypotenuse. So again, you go straight out from the right angle and you will hit the hypotenuse always. So as long as you have that relationship down, then we can define the trig ratios as follows. So we're going to let theta be our acute angle of a right triangle, and the 6 trigonometric functions of the angle theta are as defined. So we got sine is equal to the opposite over the hypotenuse. Cosine is going to be the adjacent over the hypotenuse. Tangent is going to be the opposite over the adjacent. Cosecant is going to be the hypotenuse over the opposite. Secant, hypotenuse over the adjacent. Cotangent, adjacent over the opposite. Now, frankly, these three down here, I wouldn't get too nervous about those, because as long as you know that they're linked to the ones above it, that's the important thing, because it's just the reciprocal. You can see that if you just flip-flop these, we have the sine. If you flip-flop these, we have the cosine, and so on. So really, it's just these three up here that as long as we know those, we're in pretty good shape, and we should be able to get the bottom three. So what's a little acronym that you can use? You've probably heard this before. SOHCAHTOA. And some people like to call that SOHCAHTOA. SOHCAHTOA. So that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. So it's a nice, easy way to kind of remember that. There's other little acronyms you can Google if you want, but yeah, there's lots of ways to remember that. So whatever way works for you. Now, as far as our next examples, so we do have to take some from the textbook. So let's take a pause for a second, and I'll bring that up. Okay, so if we bring up the textbook, you can see the directions just want you to find the exact values of the 6 trigonometric functions of the angle theta. So they'll give you a right triangle and a couple of the sides, and then the angle theta, so you should be able to get all the trig functions from that information. And then they give you a slightly different variation of that in problem 7, so we'll tackle both of those right now. All right, so we've transferred over our diagrams, so now let's see what we got to do. So first things first, though, we're going to need all 3 sides. If we're going to find the 6 trigonometric functions, we got to find that third side. So we should know that this is side C, so we can use the Pythagorean theorem to find it. So we'll quickly plug all of our numbers in. So if C squared is equal to 100, then that means that C should be 10. Now we don't have to worry about units or anything for this problem. So now we're good to go. So we know that this is 10, so we should be able to find all of our trigonometric values. So the sine of our angle should be the opposite over the hypotenuse. So the opposite in this case is 6, and the hypotenuse is 10. So 6 over 10, but we can reduce that down to 3/5. Cosine. Cosine should be adjacent, so again, adjacent to this angle, so that should be down here, so 8 over 10, which reduces to 4 over 5. Let's make sure we fix that. And then tangent is going to be the opposite over the adjacent. So 6 over 8, and we can see that should reduce to 3/4. So now we can get the rest of these. So remember, sine is going to give you cosecant. So if we take the reciprocal, we should just get 5 over 3. Secant should be equal to 5 over 4. And then cotangent should be 4 over 3. So again, once you have those three, then the other ones are really, really quick. All right, so similar problem, but obviously we have a different side that's missing, so we just have to be careful and solve for the right side. So remember, we can call this either A or B because it's one of the legs. So if we want to call it A, so we'd have 41 squared is A squared plus 9 squared. So 41 squared is going to be what? 1681. And lo and behold, 9 squared is 81. So if we subtract that from both sides, so A squared is 1600, so we can quickly see that A better be 40. All right, so now we should be good to go. So again, we're basing everything off of this angle here. So that's how you should base your opposite and adjacent. So be very careful. Different pictures are going to be oriented differently, so you're going to want to make sure you correctly identify your opposite and adjacent. Hypotenuse is not so bad, but it's that opposite and adjacent you got to be really careful about. So the sine should be opposite, which is 9, over your hypotenuse, which is 41. This one we can't really reduce. So cosine adjacent, so which is 40 over the 41. Tangent opposite over adjacent, so 9 over 40. And now the rest is easy. So cosecant 41 over 9, secant 41 over 40, and cotangent 40 over 9. All right. So not too bad for that first part, but let's stop there and then we'll start picking up more different applications in the subsequent videos. So see you soon.